this is where you are given a 3 cross 3 matrix A, and the question is that find all eigenvalues and eigenvectors of A with algebraic multiplicity and geometric multiplicity. That means we have to find first the eigenvalues, and then we have to find the eigenvectors, and then we have to find algebraic multiplicity and geometric multiplicity of that eigenvalues. So let us solve this question. So we are given that this is a 3 cross 3 matrix. Solution start here. So look, when we are given a matrix, we have how to find the eigenvalues of that matrix. So this simple equation gives you the eigenvalues. That is determinant of A minus lambda I is equal to 0. But what is determinant, and what A is this matrix, this is the matrix A, and what is lambda and what is I? Lambda is a scalar, that is lambda is a real number, and I is a identity matrix. This is, since A is 3 cross 3 matrix, I will be also 3 cross 3 matrix. So that means now find A minus lambda I. Since A minus lambda I, this is equal, this is a matrix, A minus lambda I is a matrix, that will be 2 minus lambda 1 minus 2 2 3 minus lambda minus 4, and this is 1, this is 1, and this is minus 1 minus lambda. What happens? Just in the diagonal elements are same. All our remaining elements are same, but these diagonal elements, you have to minus lambda. You have to, so A, so 2 minus lambda, 3 minus lambda, minus 1 minus lambda. So this is happening. Okay. Now you have to find the determinant of A minus lambda, and it's equal to 0. Now determinant of A minus lambda equal to 0. This simple equation gives, find the determinant of this matrix. It is 2 minus 1, 2 minus lambda, so 2 minus lambda into, draw a line here and line here. So product of this multiply by this minus this, okay, 3 into 3 minus lambda, 3 minus lambda, multiply this with this minus 1 minus lambda. Okay, then minus 1 into minus 4, it will be minus 4, bracket close. Now this is minus, the first it is plus, second it is minus, again it is plus, then it is minus. So ये plus है इससे पहले, so minus लिखा, so this is minus and this is minus 1 into, draw a line here, 2 into this minus 1 into this, 2 into minus 1 minus lambda, minus 1 minus lambda, minus 1 into minus 4, minus 1 into minus 4, it is minus 4. Okay. Okay. Now plus, you write here plus, and this is minus 2. Minus 2. Is it visible there? So here, okay, minus 2, and draw a line here, 2 into 1 minus 1 into this, 2 into 1 2, 2 minus 2 into 1 2, उसके बाद minus, and then minus 1 into 3 minus lambda, so it will be 3 minus lambda, and make it equal to 0. This is 0 0. Okay, so this is the determinant. Left hand side is the determinant. Okay, so 2 minus lambda, and it is 3 into minus 1 minus 3, and it will be minus thrice lambda, and it will be plus lambda, and it will be lambda square. Okay, so this bracket will be like this now. Okay, lambda into this, minus lambda into minus lambda square, and this is here also minus minus plus 4. Okay, minus 1 into this bracket will come 2 into this minus 2. Okay, 2 into minus 2 minus 2 minus twice lambda. This will be 4 plus 4, and this is minus 2. This is minus 2. Okay, okay. What happens here? Here it is minus 4. इसके बाद this is a bracket. Okay, there is a bracket because minus 1 into 2 into minus 1 minus lambda minus 1 into minus 4. So it will be minus 4, and this bracket close. Here it is bracket, and where it done. So these brackets will be given. Okay, plus this under part. Okay, so this. Okay, this is minus 2 bracket 2 minus 3, and 2 minus 3, it will be 2 minus 3 minus 1, and it will be plus lambda. Okay. It will be 2 and then minus 3. Let us put here 2 then minus 3 plus lambda. Any problem? I hope it is visible. Okay, nicely it is visible, and this is equal to 2 minus lambda, and this will be 1, 4 minus 3 1, and it will be minus twice lambda plus lambda square. Okay. Minus 1 into this. Okay, minus 1 into 4. This is minus 2, this is minus 2. That means it will be, this is minus 2, this is minus 2. That means minus 4, and this is plus 4. So minus 4 plus 4 go gone. So there will be minus twice lambda, and minus twice lambda. This and this will be done. Okay, so cancel. So this is minus twice lambda, and this is minus 2 into this is minus 1. Okay, minus 2 into minus 1 plus lambda equal to 0. Is it minus 2 minus twice lambda and then plus 4? Okay, why it is minus 2, and this is minus twice lambda, and this is minus minus plus 4. This is not here. So go. So in how to here I taken this with, because I did not write here the bracket, so I put it here. So after that I put the bracket. Okay, then it should be okay. So it will, and this is 4. Here it is. Okay, this is this and this is this. Minus 1 into this will be 4 minus 2, 2, and this is minus twice. Okay, and this is minus 2 and this will be minus 1 and plus is equal to 0. Now look, it will be 2 minus lambda into 1, right is here, lambda square minus twice lambda plus 1. This is this, and this is minus 1 into 2 minus 2, and it will be plus twice lambda, and it will be plus 2, and it will be minus twice lambda. Now look, this minus 2, this 2, this. Okay, cancel. So that means you are having 2 minus lambda into lambda square minus twice lambda plus 1 is equal to 0. Okay, now this will imply 2 minus lambda is equal to 0, this is equal to 0, or lambda square minus twice lambda plus 1 is equal to 0. If this is equal to 0, you will get lambda is equal to 2. And if this is equal to 0, you will get lambda square minus lambda plus 1 equal to 0. And then we will get lambda into lambda minus 1 into lambda minus 1, and it is equal to 0, and then we will get lambda is equal to 1 and lambda is equal to 1. From this you will get this. So lambda is equal to 1, 1 are the eigenvalues, of A. So these are the eigenvalues of A. So we have find the eigenvalues. Now we have to find eigenvectors. Corresponding to each eigenvalues, you will have a eigenvector. Now remove this. So we are needed this. Take a screenshot, or you can write in your copies. And then, so these are the eigenvalues. Oh, I have removed lambda is equal to 1, 1, and 2. These three are the eigenvalues of this. So now we have to find eigenvectors. So step 1. Eigenvector corresponding to lambda is equal to 1. Eigenvectors corresponding to lambda is equal to 1. So for lambda is equal to 1, we will find the eigenvectors. What it will be? So the name will be lambda 1. For lambda is equal to 1, eigenvectors, thus eigenspace will be lambda 1. In going to eigenvectors, we will find eigenspace. And you can find eigenvectors also. But I will find extra, you can say, I will find eigenspace. And from that eigenspace, I will write the eigenvectors. So eigenspace, okay, that means we are going to find eigenspace. So since, what is eigenvector? Eigenvector is a vector such that a minus lambda I into x is equal to 0. The set of all x such that a minus lambda I into x is equal to 0 is the eigenspace, the values of x we are going to find. So here x is equal, since it is the 3 cos 3 matrix and a minus lambda I, it will be also 3 cos 3 matrix. So this is 3 cos 3 matrix. The x will be of the form this: x1, x2, x3. Okay. This will be the form x1, x2, x3, x is equal. Okay. so now find the augmented matrix. Okay, so this is equation number 1. Augmented matrix to equation 1 will be 2 minus lambda. So now put for lambda is equal to 1, put here lambda is equal to 1, 1, 1. So it will be 2 minus 1, it will be 1. It is 1 here and it is minus 2. And this is 2, put here 2. 3 minus lambda, it will be 2. This is minus 4. Okay. And this is 1. This is 1. And this is minus 1 minus lambda. That means when lambda is equal to 1, minus 1 minus 1, it will be minus 2. So this is a minus lambda we have obtained putting lambda is equal to 1. Then since it is augmented matrix, it will be 0. So it will be 0. It will be 0. Okay. So this matrix is equivalent to first what we will do, write the first row as it is. Now we will perform row operation. R2 tends to R2 minus R1 twice R1. Okay, twice R1. R2 tends to R2 minus twice R1. So multiply here 2 and minus from this 2 minus 2 it will be 0. 2 minus 2 it will be 0. This will be minus 4 minus 4 minus 4 it will be minus 8. Oh, sorry, minus 4, and when you put here, you multiply here by 2, it will be minus 4, and minus 4 minus 4 it will be 0. Okay, and then it will be 0, and R3 tends to R3 minus R1. So it will be 0, it will be 0, it will be 0. These two are same, so it will be 0. What happens? Wow. Okay, this is 0 and this one is 0. How? So it is 1, this is 2, and this is minus 2. ठीक है, no problem. 1 by 2 minus from this 2, 4 minus from this, and this is okay. So correct. Okay. So we'll lambda is equal right here 1, 1, 2. Okay. So if this lambda are shifted to here. Okay. So this matrix is obtained by putting here lambda is equal to 1. Lambda is equal to 1 put here. So we have obtained this matrix. This matrix is obtained by putting lambda is equal to 1. And then we have performed row operation here. Okay. Now look, observe that x1 is okay, x2, x3. X2 and x3 are 3. Okay, 3. So x is equal x1, x2 and x3. Okay, so this is equal. No, you have to write. Okay. Now we can find eigenspace. So eigenspace E corresponding to lambda is equal to 1, eigenspace will be capital E1. This will contain the vectors x1, x2, x3. Since x2 is free, right here x2, x3 is also free, right here x3, bracket. Now this is a position for x1. Okay, this is the position for x1, and x1 will be, look from here, this is minus 2, put here x1, x2, x3. So x1 will be minus 2 when goes to the right side, it will be positive 2, and this is x3, 2 x3. We are simply putting here x1, here x2, and here x3, and this is equal to 0. Then look from here, x1 is equal, this will become here, twice x3, twice x3, twice x3, and it will become x2, minus, it will go there, then x2, minus x2. Okay, okay. So this is x1, this is x2, x3. We have find from this. Remove this now. Okay, okay. So this is the eigenspace such that x2 and x, here values are x2 and x3. So if this is x1, x1 for x1, it is making with x2 and x3, and this is x2, x3. So x2 and x3 belongs to R. These are real number. X2, x3 are real. This is the eigenspace. Now you can find eigenvectors for x2 is equal to 1, x3 is equal to 0. Since these two are free, you can choose any values for them. I am choosing x2 is equal to 1 and x3 is equal to 0. We get the eigenvector. For this, we get the eigenvector. What that will be? X is equal, put here x2 is equal to 1, x3 is equal to 0, x2 is equal to 1, x3 is equal to 0, and then x1 will be, what will be this? x2 is equal to 1, x3 is equal to 0. When x3 is equal to 0, this is 0. When x2 is equal to 1, this is minus 1. So you have then minus 1. So x is equal to minus 1, 1, 0. This is eigenvector, one eigenvector. I will find another eigenvector also here. Okay. This is important. Okay. For x2 is equal to 0, x3 is equal to 1, we get eigenvector x, that will be, we have written x, right? Okay, so this will equal to, so what we have taken, x2 is equal to 0, x3 is equal to 1, and what will be x1? This is the x1, so x1 will be put here these values, x3 is equal to 1, when x3 is equal to 1, it will be 2, minus x2 is equal to 0, so it will be x2 shift 2. So this is what, this is x1 is equal to twice x3 minus x2. Okay, I have zoomed this here. Okay, So this is, so put here x2 is equal to 0, it will be 0, x3 is equal to 1, it will be 2. So only 2, so 2, x1 is equal to, so this is another eigenvector. One is this, another is this. So find eigenvectors. I have find 2 eigenvectors. You can find more eigenvectors from using this. Okay. So eigenvectors corresponding to lambda is equal to 1. These 2 are eigenvectors. And there are 2 free variables here. So find all eigenvectors we have done, and eigenvectors, okay, eigenvalues we have done, and for lambda is equal to 1 we have find the eigenvectors also. So this is eigenvector, this is eigenvector, these 2 are eigenvectors corresponding to lambda is equal to 1. So now we have to find the eigenvectors corresponding to lambda is equal to 2. So what we have obtained, take them. So we have obtained lambda is equal 1, 1, 2. Second, we have obtained eigenvector. Eigenvector. They are x is equal. Eigenvectors are these 2 are eigenvectors. Minus 1, 1, 0, comma. Second is this is 2, 0, 1. So now we can remove this. Okay. Now right here step 2. Eigenvectors corresponding to lambda is equal to 2. So a minus lambda is equal to 0 here. Okay. So put lambda is equal to 2. Put lambda is equal to 2 here. A minus 2i. So it will be a minus 2i. So a minus 2i. And what will be this? You will get from this. This is from here. What will be that matrix? The matrix will be put here 2. It will be 0. It is 1 and this is minus 2. 2. This is 1 and this is minus 4. This is 1, 1 and this is minus 1, minus 2. It will be minus 3. So this is of we have obtained this matrix. Okay. I can remove this. Now also augmented matrix we have obtained. So augmented matrix corresponding to 2. Augmented matrix corresponding to 2. So it will be augmented matrix. So this is a minus 2i. Okay. And put here this is 0. Augmented matrix. So this is the augmented matrix corresponding to a minus 2. Okay. A minus 2i 0. So this is the augmented matrix. This is equivalent to this. Now perform row operation here. First this row will be shifted to here. You say you can do this by similar process. You can find, okay. So we have find all eigenvectors or eigenvalues and eigenvectors corresponding to lambda is equal to 1. And now the remaining part to find the eigenvectors corresponding to 2. So okay. So let us, I think you solve this by yourself. First you have shifted 1 minus 3 to here, and this is 2 1 minus 4 0, and this is 0 1 minus 2 0. Okay. Shifting R1 to R3 and R3 to R1. You can do 1 1 minus 3 0 and it is 2. Multiply here 2 by and minus, it will be 0. Okay, 2, it will be minus 1, and this is will be 6. Okay, 6 minus 6 minus 4 minus 6, it will be minus 4 minus 4 minus minus 6, it will be 2, it will be 0, and this is 0 1, this is minus 2 0. Okay, now you will get 1 1 minus 3 0, and it will be 0, it will be okay minus 1, it will be 2, and it will be 0. Now it is 0 and it is 1, and this will, when you weigh this 0, perform rt tends to rt plus r2, it will be 0 and it will be 0. If this is right, I am not doing it well, so you can perform row operation by yourself and check, is it right, is it the right augmented matrix, and it is the reduced row reduced matrix, is it okay, you check. Now we can find this is x3. If it is true, you can find this x3 will be the free variable here, and you can find. So I hope remaining part will be do by yourself. And now I am going to algebraic multiplicity and geometric multiplicity. Algebraic multiplicity of lambda is equal to 1 is 2, because it is repeating 2 times. Algebraic multiplicity of lambda is equal to 1 is equal to 2. Algebraic multiplicity. Algebraic multiplicity. Lambda is of 1 of lambda is equal to 1 is 2. And geometric multiplicity of lambda is equal to 1. In a geometric multiplicity, lambda is equal to 1, we have find 2 free variables, so it will be 2 is 2. And here algebraic multiplicity of lambda is equal to 2 is, algebraic multiplicity of lambda is equal to is 1, because 2 is repeating only one time, so it will be 1. And geometric multiplicity, here it is only one free variable, and geometric multiplicity of lambda is equal to 2 is 1. So you can find, if it is correct, I have not performed this very well, you can check, I may be wrong also. So this is a very lengthy question, and so many times I have done it, so okay, thank you.